Morning, guys. Kind of just going to be a repeat of what Jessica decided to present about. So, I don't know. I guess she copied me. So I'm going to talk about homeostasis. Not going to be as in-depth with the caloric side of it, but I'm going to talk more about into the dilating of capillaries and whatnot. So what is homeostasis? So homeostasis is just the state that we're constantly trying to achieve. So 37 degrees Celsius, which is 98.6 degrees Fahrenheit. You know, our brain is constantly trying to achieve this state. You know, in Louisiana, we're always trying to cool our bodies down. If you're up north, trying to warm it up. So why is it so important physiologically? As my guy's showing right here. So in the cells, we have enzymes. So these enzymes, they're going to carry out these chemical reactions. And what happens when we aren't, in our wanted state of 37 degrees, it changes the shape. So the enzymes are based on, they're temperature dependent. So if it gets too cold or too hot, the chemical reactions can be interrupted. So how do we know if we're hot or cold? So the area of the brain that controls, it's like in all the experiments. We have different pressure taps, different thermocouplings. Our body is essentially just a much more, complicated system. So we have a bunch of thermocouples around our body, and they're all sent to the area called the hypo. So yeah, so the hypothalamus. Yeah. So how do we cool down? So this is important for us living in Louisiana. Next slide. So how's a broad shell? So as Jessica discussed, so your capillaries, right? So you have your capillaries that are below your dermis, and whenever you're starting to get hot, you start to kind of get red, rosy cheeks, or your skin can, your pigment can kind of darken. The reason is because of the vasodilation. So you're increasing blood flow. It's getting closer. So just imagine, when we did our heat exchanger experiments, right? So you vary the flow rate. You can have an increase in your volumetric flow rate or your blood, and then that radiation will leave your body through the dermis. And then similarly with other experiments, we'll have evaporators. So when you sweat, you have your sweat glands. You can see right here that coil up, and what passes along the sweat gland, you'll have sodium and water that will go, and it'll fill up the sweat gland, and it'll go to the top. So what's happening is similar to what Charles was talking about. What was it, the Clapeyron? Yeah, the Clapeyron. So the latent heat of vaporization. So you're trying to change, the enthalpy in order to vaporize. So when we walk outside and we start sweating, we want that cue, so that input cue that causes vaporization to actually occur with your system is the heat transfer from your actual surrounding skin. So that's what's happening. I thought it was more due to convection, but it's actually because of the vaporization occurring. So it's never cold in Louisiana, but if we wanted to warm up, we definitely have the first method down. I tend to not drink, so when it comes to drinking like whiskey or like red wine, it's getting colder, so I'm definitely going to do more of that. This compared to a cold brew, in the middle of the summer. But yeah, no, when you drink alcohol, it actually, like I was talking, vasodilation, so it'll dilate your capillaries, so you'll actually warm up. So today, between classes, go take a shot of whiskey. So then the second one, I guess you can go, get a pump in between classes as well. So as Jessica discussed, muscle constriction, and shivering. So your muscles are contracting, avoid Ryan Coleman, and ATP is released. So yeah, vasoconstriction. It's the heat you're lessening the heat transfer, so it's bringing it in closer to your body, and then goosebumps. So when you get goosebumps, when you go outside, what's happening is, just imagine like a bear, right? So why are bears so warm? They got all this fur. Yes, it's like a blanket, but what's happening, there's these little muscles that are attached to your hair follicles, and when they raise up, it's reducing the air that's moving across your body. So when you turn on a fan, right, you're increasing the convective, stuff that's occurring on your body. So your hair stands up, it's trapping more air close to your skin. So yeah, that's what happens when it gets cold. You get some goosebumps. And then also, you don't have to go back, but when it comes to you know, people that live in colder climates, their metabolic rate, kind of what Jessica was talking about, their resting metabolic rate is actually found to be a little higher because their body is naturally adapted to where they're, they're just having to stay warmer compared to us. So it's probably why our obesity rate's so high. So here's just some last facts that I've covered. So as you go further from the core, your heat is going to dissipate. Your heart that's acting as a pump, it's moving all that heat around. But then kind of in heat transfer. So in Dr. D, when you assume a ideal thin case, right? And you got a tall dude with some long toes, like in Andrew, his flops. His toes are going to be naturally a little colder, because they're acting like just these perfect convective fins. So yeah, that's just one thing I find is interesting. Andrew's toes. So with the latent heat of vaporization, so when you have high humidity, like in Louisiana, it decreases the vaporization that occurs. So that's why we get so hot. Hot face Fred talked about that. People in colder conditions are just in better shape than us. So any questions?